Good morning, one and all. Myself, Dr. Balaji Maram, working as a professor, SR University, Warangal, Telangana, India. Today we will discuss about the process execution and termination with the help of exec system call. Here, the exec family of system calls is used to replace the current process image with a new program. Earlier we have discussed about the parent and child process. When parent creates a child process, they both are executing parallelly, uh, and the parent may wait for child termination and so on. But here it is entirely different. EXEC it simply replace the present process with a new process. Means in the place of current memory space, a new process will be executed with the help of exec. After successful exec function, a new program starts executing from its main function. The PID remains same. Already I told the memory space is same, the PID is same. But memory, stack, heap and text segmentation are replaced with new process. These system calls are part of POSIX and are implemented in system based on Unix and Linux kernel. What is the use of exec? To run a new program from a process, commonly used after fork only, means usually we are creating some child process. After execution of some part of the child process, when we want to replace the existing process with a new process, definitely it is very useful. Used in shells like bash, used in process creation and control. So what are the means comparison between different forms of exec? First one, execl. So argument type is it is list, and path variable is there. Means any path directly we can give. So here there is no need to give any path, and environment handling, that is inherited. Next, execv. V means that is like vector, that is argument type is array, and there is no need to give any path. Next, execlp. L means like that is like list, and path means definitely we need to give path means path of the process. Next, execvp. So here argument type is array only, and we need to give path. And execle, again argument type is list and no need to give any path. And execve, same array and no need to give any path. So this is the comparison among different forms of exec system call. First one, execl, execute with argument list, no path. So already you have observed. Execute a program using the full path. Arguments are passed as a list of parameters. Means first of all we need to create one list. That list contains different values or parameters. There is no need to set in dollar path, that is environment variable, and inherits the current environment. Now what is the syntax? Here syntax means return type is integer, execl, and first one is constant char path, that is means like file name. Next, constant char arg of 0, arg of 1, arg of 2 and so on. Now we will check what is the simple example on execl. So here the header files are hash include stdio.h, hash include uni std.h, int main begin, printf before execl, and next exec system call execl, and here that is when we want to execute some ls command, means /bin/ls, and what are the arguments here? Ls is argument, -l is argument, null is argument. So here if any error is there, it gives some error message execl failed, return 1 closing. But here when we execute the program, it simply executes ls minus l command. Okay. Next one, execv. So here execute with argument vector. Argument vector. Here everything is available in the form of a array. Executes using full path. Arguments passed as an array. Does not set $path, that is environment variable. Environment is inherited. Okay. So here what is the syntax? Int execv. First one is path of the program process. Second one is array. Okay. Char star constant argv. Okay. What is the example? So here again header files are same. Hash include stdio.h, hash include uni std.h. Int main begin. So here everything should be available in the form of array, that is char star args bracket is equal to first argument is ls, second argument is -j, third one is null, last one is null. That is end of the array. And printf before execv system call. Next system call execv. First one is path. We need to give path of the command /bin/ls. Second one is name of the array, that is args. Okay. So automatically it executes a new process with the help of the current memory space and current process ID. No need to miss it. Will not, the process ID will not be changing, but it will execute a new process. That is the beauty of exec family system calls. Next, p error. Suppose if it is not executed successfully, automatically it displays some message execv failed, return 1 closing. Arguments are stored in the array format. So here you need to check arguments are available in the form of a array. Okay. Next, execlp list place path search. Okay, here argument should be available in the form of a list, and here it needs to check environment variable $path. Okay, arguments are passed as a list. First of all, we need to create a list with the which contains the parameters. Second one searches the program in $path, that is environment variable, predefined variable. Here no need to give full path of the process. What about syntax? execlp. Here return type is integer, and the first argument is name of the file without path, name of the file only. Second one that is like arg0, arg1, arg2 and so on. Okay. Here this is the example. What about the example? Again same header files, hash include stdio.h, hash include uni std.h. Here int main begin printf before execlp. Okay. Here execlp, the first one is date. Directly you can give the name of the process or name of the command, that is date. Here what about path? Here no need to give any path because date will be checked in the environment variable $path. Okay, $path contains the list of the pre-existing paths. So in all paths it checks where the date process is available. Second one is argument, that is date. Third one is null, means end of the arguments. Next, P error execlp failed, return 1 closing. So here it finds date from system path. Okay, that is environment variable $path. Next one, execvp. Okay, here it is like vector plus path sets. Arguments passed as array, sets executable in $path, commonly used in shell programming. Usually we are using this specific system call only. Here what about syntax? The return type is integer, execvp. First argument is file name, second one is array name, that is argv. So here what about the example? Hash include stdio.h, hash include uni std.h, int main begin char star args is equal to the process name or file name only, that is ps. ps is the file name. Second one is the arguments are like -ef comma null. Null means that is end of the array. Next, printf before execvp. Next, command means system call execvp ps comma, that is that is file name. Second one is args, means that is array name. Next, if any error is there, it simply prints error message, that is through p error of execvp failed, return 1 closing. So here it tries to execute the ps command. If any problem is there, automatically it displays some error. Otherwise, the ps process will be executed. That is nothing but one predefined command only. So that command will be executed here. What about actually how to use exec family of system calls effectively? So here one of the best practice is it is very useful with the help of fork system call. Fork. Here also we have discussed about fork. So fork simply creates one child process. After creation of a child process, two processes will be existing. One is parent process, second one is child process, and both processes will be executed parallelly. And sometimes based on the program, the parent process may wait for termination of a child process. Otherwise, sometimes the parent process will be executed and terminated before the child process. So in such case, such child processes are called orphan process. But sometimes the child process may execute and terminate before parent process. In such scenario, it may create zombie process. Means when the parent process is not able to check the progress of the child process and the child process is terminated, in such scenario the child process entry is still available in the process table. Such processes are called zombie process. So that is the reason when the parent creates a child process, the parent should monitor the progress of the child process. When it completes its execution, the parent should take care about child process termination. Then it should intimate the kernel. Then the kernel will remove the entries of the child process from the process table. Then it will not comes under zombie process. So that is the reason wait and wait period system calls are very helpful for parent process. So here how to means write a program with the help of fork and execlp. So here the system calls means the header files are hash include stdio.h, hash include uni stdio.h, hash include sysbytypes.h. Here the main program and it return type is that is like int begin PID underscore t PID is equal to 4. So this is parent process. This parent process create a new process that is called a child process with the help of the system call that is fork. Now here if PID is equal to 0, so when it is a child process, then the PID value is 0 in such scenario. Means in the case of a child process, PID will be 0, then automatically the child process will execute the system call execlp within bracket ls is the process name or command name, comma the list of arguments ls hyphen l and the last one is null. Suppose if it is not child process, if it is a parent process, so else case will be executed. So in such scenario, it simply prints one message: parent is waiting. Okay, then return 0, then closing. So here the important point is the same code will be copied to child process also, but the statements which are after fork will be executed by the child process. Okay, so that is the difference between the parent and child process. So here after creation of a fork, then the child process is able to execute a new process with the help of execlp system call. Okay, then parent creates child, child replaces itself using exec system call. What about wait and wait period? Just now we have discussed about wait and wait period. Here in Linux and other Unix operating systems, wait and wait PID are system calls used by the parent process to synchronize with its child process. Suppose when there is a parent, the parent has multiple child process. Definitely the parent should take care about execution of a child process, and when child process is terminated, it takes care about the child process entry in the process table, and those should be removed from the uh, uh, process table. Okay, that is the responsibility of the parent process. These system calls allow the parent to pause execution until one or more child process terminate and to collect their exit status. Exit status means whether it is successfully under execution and it is executed successfully. Okay, proper use of these system calls is essential to avoid zombie process. Just now we have discussed. So when it collects the exit status information from the child process, automatically it eliminates the creation of a zombie process. Otherwise, after means termination of a child process, and that will become like a zombie process. Okay, so there is no use of such a process. That is called it is a zombie process. So here, what about wait system call? The wait system call causes the parent process to block until any one of its child process finishes execution. Once a child process terminates, wait returns the period of the child process which is means terminated the child and stores its termination status in an integer variable. So when the child process is under execution and when it completes its execution, automatically it gives some message to the parent process because the parent is waiting through the system call, that is wait system call. What about syntax of wait system call? PID underscore t wait of int star status. If there is no child process exists, wait means system call returns -1. The termination status can be analyzed using macros such as, so here two constants are there. Here means W if exited status. Okay, checks if the child exited normally. Otherwise, already exited. Suppose when you want to take the status only, so here W exit status of status retrieves the exit code. Retrieves the exit code. Wait is simple to use but lacks flexibility because it can't wait for specific process and always blocks the parent until a child exists. Okay. Anyway, it is the miss. Use of the wait system call. Now we will check the example. Okay, next wait PID. Later we will discuss about examples. Now wait PID system call. So here wait PID system call is more flexible and powerful alternative to wait. It allows the parent to wait for a specific child process, perform non-blocking waits. Okay, here in the previous case, the parent should block until termination of a child process, but here it is non-blocking wait. Means whenever the parent has some task, it can continue with the task and parallelly it can wait for the child process. Okay, here handles multiple child process selectively. Okay. What about the syntax? PID underscore T, wait period of PID underscore T, PID, comma, int start status, int options closing. So here, what about PID parameter determines which child to wait for? Okay, that is which child. Suppose it has some 4 childs are there, but which child? It has to wait for termination of which child. That is first argument PID. If PID is greater than 0, wait for a specific child. If PID is equal to -1, wait for any child. That is almost similar to wait system call. Wait for any child, anyone. Suppose 4 children are there. Suppose if child 1 is terminated, or 2 is terminated, 3 is terminated, 4 is terminated. In any case, it takes the some response. But here, if PID greater than 0, means suppose the PID of the child process is some 300. It waits for the termination of a child process 300. Okay, PID is the 300. Suppose if it is -1, means we don't want to give any specific child process. We want to give any child. In such scenario, we need to give -1. Next, options, third argument. Options parameters 0 blocking call. Blocking call means suppose almost we have discussed the same point in wait. The wait system call blocks until termination of a any child process. But here that is the option we need to give. If it is 0, it is like blocking. If it is W no hang means that is non-blocking. Means that is our wish. When we want to block the parent, then we need to give 0. Otherwise, we need to give the constant W no hang. So here, wait PID is widely used in server applications and concurrent programs. Here, this is the example, simple example. Try to understand. Here, means header files are there. Hash include stdio.h. Hash include uni std.h, hash include sys/wait.h, int main begin PID, PID underscore t, PID is equal to fork. So here it creates one child process and it returns the PID of the child process. Now the next code will be executed parallelly in child process and parent process. If the condition, if PID is equal to 0 means when it is a child process, if this code is executing in child process, then PID value is 0, automatically that true code will be executed. that is printf child is running sleep 3. So automatically it sleeps for 3 seconds. Next printf after sleep printf child exiting. So the same code will be executed in parent also, but in the case of parent else code will be executed. Printf parent waiting and wait null means that is like blocking. So here the parent should wait until termination of a child process. So after 3 seconds the child will be exited successfully. Then it prints child exiting. Then the control comes to the parent. uh, then it will be comes under non-blocking. Then one more printf will be executed in parent side. Parent resumes after child exits, then closing. That is about the previous one about wait. Now here, what about wait PID? Here same thing. Int main begin period underscore t PID is equal to 4. Int status if period is equal to 0, that is child process sleep 5. Then printf child exiting. Else case, suppose if it is parent process, then else will be executed while one means always true. Then begin period underscore t result is equal to wait PID of PID that is like address of status. Next w no hang. W no hang means that is non-blocking. Okay. Then if result is equal to 0, child still running sleep 1, else child finished, then break. Okay. Then here it simply continuously it simply checks whether child is running or it is exited. So here when the result is 0, suppose when child is running, then the wait period returns 0. Okay, if it is 0, child is still running, then sleep 1 means after sleep again it checks whether it is still running or it is exited. Okay, here blocking wait PID equals to wait. Okay, suppose if it is a blocking means already we have discussed. In the case of a wait PID function, the third argument should be 0, then it is equal to blocking. So when a wait PID is a blocking, almost it is similar to wait only. So here, same example, int main begin period underscore t, period is equal to 4, int status, period is equal to 0, sleep 5, child exiting, else while 1 begin, result is equal to wait period of PID, comma, address of status, then 0. 0 means non-blocking, 0 means blocking. Okay, if result is equal to 0, child still running, sleep 1, else printf child finish, break. Then break means automatically it will exit from the while loop, because the parent don't want to wait for completion of all childs. If any one child is completed, then it tries to exit from the loop. So that is the reason here we have taken the break uh, keyword. One more example. Here int main PID underscore t PID int status PID is equal to 4, then PID is equal to 0 means it is a child process. Then printf child PID, then it tries to get the PID of the child process, that is get PID, then sleep of 2, then child is exiting, then exit of 5. Else begin parent process PID underscore t child underscore PID wait of ampersand status. So automatically it waits for termination of a single child process. Printf parent collected child PID, then if W if exited of status, then it indicates child exit status, that is if already exited, then it tries to take exit status of child PID. Then the function name macro name is w exit status of status. So automatic. What about output? Initially it brings child PID, then child is exiting, and parent collected child PID, that is 5231, and child exit status, that is 5. Then it is also similar. Then it is comparison, weight and weight PID, child selection, any child, here it is a specific child, blocking mode, always blocking mode, here it is blocking or non-blocking, flexibility in weight it is low, flexibility in weight PID it is high. Uses simple programs, but weight PID most of the cases is server.